Hi everyone. Today let's look at the LeetCode problem 253, meeting rooms 2. Given an array of meeting time intervals where interval of I is equal to start I, end I. So you are given the meeting time interval. Okay. Intervals, basically an array of intervals. Okay. Return the minimum number of conference rooms required. So that means if there are overlaps, if there are two meetings going on at the same time in parallel, then you need two meeting rooms. So if you take this example this example, you can see, right, the first meeting runs from 0 to 30. The second meeting runs from 5 to 10. So that means I have an overlap at this point of time. So in this, between 5 and 10, at least I need two meeting rooms. Same 15-20, this has an overlap with 0-30. So in this, when between 15 and 20 also, I need two meeting rooms. So now at any given point, you need at least two meeting rooms to have this meetings going on. Now, just like any of the intervals problem, the first thing I would recommend is to draw this in a number line, because that makes it very clear. Now, if you see here, in this particular case, this meeting and this meeting are overlapping. So at this point, at least, at this point, I need two meeting rooms. And the same with this case. So the one thing I want to mention is the end time of a meeting, and if another meeting start time overlaps, it's okay. It's considered as it just got over, so the next meeting can start. Just like any meetings that we would have set in our office, same way. So so you can see, right? So here and here also you will need two meeting rooms. So the maximum, so at any given point of time, minimum you need two meeting rooms to run this discussions. Now, how can we solve this? The first thing is we'll have to sort this. Sort the intervals in based on start time. So once you sort this, you can see one way to do it in a brute force way would be, so I inserted 4-9 first. So imagine this is your first one, and then we have 4-17. So what we can do is we need to find to the left how many meetings are there whose end time is greater than 4. So there could be another meeting, for example, which was this way. For example, it started at 2 and ended at 8. Just giving you an example. Okay. So in this case, at this point, I would ideally, when 4-17 comes in, I would ideally need 3 meeting rooms, because I have to first, because there is an overlap with this 9 and there is an overlap with this 8. So at that point, we have to look back at all the meetings which started before 4 and ends after 4. So we'll have to keep looking back. So if you take that approach, the time complexity will be order of n squared. There is a much more elegant solution where we can just use a heap to keep track of all the a min heap, basically, to keep track of all the end times, basically, of the previous meetings in the output, the previous meetings, meeting intervals. So let's take this example to start with. I'm also including, to make it a little bit more complex, let's include 2-8 also. So if you see here, first we will have 2-8. Okay. At that point, just insert this to our min heap, the end time to the min heap. Now we will have 4 9. See whether 4 is less than 8. So as you can see, 4 is less than 8. So what we'll do is we will also insert the end time of this particular interval. Now at this point, if you see, I will have 2 meetings, so I can just keep track of my heaps size. Okay, so at first the heap was empty, so when I saw 2 8, we just insert, so the heap was empty, we just insert 8. So that means at this point we just need 1 meeting room. We can just use the heap size to determine that. Now we come to 4. 4 is less than 8, so that means we just insert the end time of this particular meeting also. Okay, and then again check the size of the heap. So at this point we need at least 2 meeting rooms to take care of our conferences. Now the next one is 417. 4 is less than, so this is a min heap, so I'll put it here. Okay, so it is still less than the top of the heap. So that means whatever is in the heap now, all those conferences are going on because it's a min heap, right? So that means any value other than 8 is greater than 8. So at this point we will need 3 meeting rooms. Now we will also then insert 17. Okay, now is the tricky part. Now we come to 9. Okay, in this case we cannot tell that we can just blindly insert, because insert this end time. The reason is, if you see here, the 9 is, this 9 is greater than the top of the min heap. 9 is greater than, so if you see the top of the heap, it is 8. So that is greater than, 9 is greater than 8. So we can take out 8. Okay, 9 is greater than or equal to 9. So that also we can take out. Okay, but 9 is still less than 17. So we'll just insert 9 here. Okay, so now at this point we will just need another, basically I'll just put it here, another 2. So the final answer will be 3, because you need 3 conference rooms to at least run all these meetings concurrently. I hope the explanation is clear. Now if you, with so that means our using this one, our time complexity will be the time complexity of the that we needed for sorting, that is n log n, and our space complexity will be order of n for the heap. Now let's just dive into the code. So first let's sort the intervals. So this will be sort intervals dot begin, intervals dot end. That's it. So this is in ascending order. We'll sort it in the ascending order. Okay, then the next step is for auto and I. So we'll take each interval, okay, in this interval array and see how to handle it. As mentioned, we also will need a min heap. So our min heap will be priority queue. So it's a min heap. So we'll have vector int, and this will be greater. And let's name it min heap. Okay. Now what we'll do is, while not min heap not empty, okay, and min heap or dot, so we'll put it this way, I of 0, which is the start time. Okay, that is start of I is greater than or equal to min heap dot top. Okay, because that means those values are, those conference room end times are no longer required. Okay, because we have gone past that, because since it's already a sorted intervals. Okay, and I of 0 greater than or equal to min heap dot top. We'll just do a min heap dot pop. At the end, we'll just push the current min heap dot push I of 1, which is the end time of the current interval. Then we'll have another variable to keep track of the max rooms. I can put it as min rooms also, minimum number of rooms that is needed. So that is, let's start with 0, and this is min rooms is equal to max of min rooms comma min heap dot size. So now let's see. Min heap dot size. That is because of the type checking. And number oops is equal to this one, and I think this will work. Okay. Nice. This looks good. That's it for today. Thank you.